Hello and welcome to Pete's Garage. Today I'm going to go in depth on my New Holland 269 Hayliner square baler. New Holland made a lot of balers through the 60s, and frankly I can't keep all the numbers straight, but they all shared a lot of the same mechanical components. I've been through this baler not from the ground up, but I've replaced almost every bearing in it and all the wear parts that needed replacing, and it's got a nice new coat of paint on it and a new set of decals. So in this video I'm going to go through how the baler operates, how each of its components work, how the drivetrain works, how fast it bales, when it was made, its mechanical specs, pretty much soup to nuts, so stay tuned. The New Holland 269 Hayliner was made between 1964 and 68. This one was one of the first farm purchases that we made when we started farming in 2013. I paid $1,200 at a consignment auction for it, and they seem pretty common around here, although I don't know how many total were made. I've seen probably 10 at auction since I bought this one. This baler makes 14 inches high by 16 inches wide bales, and the bale length is adjustable, and I'll get to that in a few minutes. This baler runs off of a 540 RPM PTO shaft, and the plunger operates at around 65 strokes per minute. Strokes per minute is what determines how much capacity a square baler has. So for comparison, a high capacity modern baler operates at around 95 strokes per minute, which means you can feed that baler a lot faster with hay and it'll kick out bales faster. Although haying experts will disagree with me, an optimum bale is usually around 15 strokes or flakes in the bale. So that means that this baler will put out about 4 bales per minute in comparison to a modern baler, which can put out 6 or more bales in a minute. I've got this baler hooked behind my International 656 tractor now, which is about 65 horsepower, but I've run this bale and it runs just fine behind a 20 horsepower tractor. That's one of the great things about old machinery. No excessive horsepower required. I ran it with my Farm All H for years and the pair did just fine. Now for the meat of this video, which is exactly how this baler works, because I think it is so cool. I'm going to go through the baler from the PTO input all the way to it spitting a bale out the back and show you how each step happens. I think this stuff is cool to the farmer, the mechanic, and the layman alike, because the technology still holds through to modern balers. They work in mostly the same way. The tongue on this baler swings, and you can see the pinhole. This is road transport position. The tongue swings in so that the baler tracks behind the tractor. Now, originally there was a rope that ran up the tractor. I just have a wire here. And what happens, and this is pretty cool, when you pull on the rope, it disengages the pin here, but this lever goes down into the tongue and is connected to a steel cable which runs straight back around a pulley and then over to the right tire, and there's a pin that goes into the right tire hub into a series of holes that are in the hub and lock that right tire in position when you've pulled the rope back. So that with that tire locked, you drive the tractor ahead and the baler swings around into field position where the pickup head is riding on the right side of the tractor, feeding the windrow in. Up front, power comes into the baler via this PTO shaft, and it comes into this big heavy flywheel, and this big heavy flywheel is what gives the baler momentum as the plunger packs hay. In front of the flywheel we've got two things. We've got a dry disc slip clutch, so if the baler gets overloaded this clutch will slip, and you've got an overrunning clutch, which is a set of pins that ride against a sawtooth wheel, and if the baler's running faster than the PTO, those pins skip out of the wheel and make a click, click, click sound. These balers came with 2 PTO shaft options, and that was the difference between, say, a 269 and a 268. Some of them only had 2 PTO joints on the driveline, so there was one here and one at the tractor. This one's got 3, one at the flywheel, one in the middle, and one at the tractor, and the effect of this is that you can turn the baler tighter with less stress on the U-joints than you do with one with fewer U-joints. In addition to the slip clutch here, there's also a shear bolt that connects the PTO driveline to the flywheel here, so if the baler gets overloaded, the clutch can slip or the bolt can break. Coming back from the flywheel is directly connected to a hypoid gearbox here, and what the hypoid does is it changes the direction of rotation from being in line with the tractor to being this way, and it directly powers the plunger. And on the other side of the gearbox, it drives the chain and the belt. The chain drives the knotters and the belt drives the pickup. So all the power comes out of this one gearbox here. From the gearbox up front, you've got a belt driven off the side of it, which comes to this pulley here, and this is the pickup drive pulley. This pulley is connected to a shaft that goes all the way through the baler to the other side to run the sprockets and chain that power the pickup. So this is the right wheel, and this is where that shaft ends, and there's a sprocket and a chain drive here. The chain drive runs around in here and powers the rotating pickup head. This pickup is adjustable. It's in the up road position now. To put it down, all you do is undo the clip, pick it up a little bit, and let it down. There is a spring on the other side which gives the pickup head some counterweight so that it floats instead of riding down on the ground with its full weight. This is the pickup head. So these teeth come around and around, pick up the hay, and they're on a cam wheel on the end so that the teeth change position as they're rotating around. So when they come up here, pretty soon after this position, they'll dive down and go back under in the retracted position, come out to pick up hay. This keeps the hay down, so it starts to pack the hay down a little bit. And once it gets through the pickup, there's a set of teeth that are on a trolley that go back and forth, and they bring the hay from the pickup and pack it into the bale chamber. There's an access door here in the back side of the baler. You open it up, and this is the carriage that holds the feeder teeth. These are the feeder teeth. They're spring loaded so that when they're pushing hay that way, they're down, and then when they come back, they ride up on the hay, so they push in one direction. This whole carriage is mounted on these two tracks, so it slides along these two tracks. They curve up when they get to the bale chamber, and that way the pushing teeth release the hay when they get to the bale chamber, and then they come back. Although many things on this baler work just about the same as today's balers, New Holland seemed to be tinkering with the feeder teeth design at the same time almost, because balers that were made from a similar period as this have different designs for feeder teeth. Some they rotate on gears and come up and down with the rotation and kind of feed the teeth in this way. So I don't think New Holland was ever completely happy with the feeder teeth design. And other manufacturers like International and John Deere used augers here to push the hay instead of feeder teeth, and they had their own claims about how much better they were because they pushed the hay in continuously. But this has always worked well for me. One major thing New Holland advertised about this baler as being cut above the rest is that there was no chance of the feeder teeth coming out of time with the plunger. So you always want the plunger to be on its forward stroke when the feeder teeth are all the way back here. You don't want them coming together at the same time, or the feeder teeth are going to get ripped off the baler. And older balers used a chain or a belt sometimes to power these feeder teeth, and it would come out of time if something slipped. Instead, this baler's got a solid arm that drives the feeder teeth, and it comes right off of the plunger so that the two stay in time all the time, no chance of them coming out of time. The sequence for this baler is after the hay comes in on the pickup, the feeder teeth slide and deliver it to the bale chamber. After they've delivered a load to the bale chamber, the plunger comes up and packs that hay into the bale. Now on the side of the plunger is a knife, and that mates with a knife on the body of the baler, so the two cut the hay that's piled on the side of the bale chamber, making cut hay on the end of the bale and forming the bale. It's really hard to see the knife because there's so much stuff in the way, but here is the knife on the plunger. I can't even get my hand in there. Here's the knife on the plunger, and then the mating knife on the baler is right here, and so the plunger slides right past that knife. What we call the bale chamber is not really a chamber because it's only got 4 sides of the chute, and then the plunger, which comes in and makes the 5th side of the chamber, it doesn't have a 6th metal side. When this is packed full of hay, the 6th side of the chamber is actually the hay that's come before it, that's packed in. So as that plunger comes forward, it packs hay into the chute against the already packed bales, which would be coming out through this chute. So it packs them against that bale. What keeps the bale in place on the plunger's retraction stroke, that is when the plunger is all the way back and the hay's just sitting there, what keeps it packed in is there's hay dogs on the top and the bottom of the chute, which trip upward after the hay is packed and hold that hay in place. They're just teeth that come up and hold it. The other thing that keeps the hay packed in place are the hay wedges, which are on either side of the bale chute here where the bale's forming in this area. And they keep the hay from going backwards because they're shaped like this. They're shaped like this with a sawtooth. So you can add or subtract hay wedges down the chute depending on how tightly you pack the bales and how you want them formed. The main mechanism though for controlling how tightly the bale is packed is this right here. And it's down because there's no hay in it. But this pinches against the hay as it rides through the chute and makes it harder for the hay to move through, which in turn makes the plunger pack the hay more tightly as it's hitting the already formed bales in the chute. And you just adjust this on both sides through these threaded rods and it moves this up and down. The length of each bale is kept track of by this star wheel. So as the hay's moving through here, this star wheel turns because it's got teeth riding in the hay in the bottom. And see, this arm over here is going up. Now when the star wheel hits that trip, it trips the knotters to start working. The bale length is adjustable by just moving this collar up and down so that when this resets, it'll reset down to wherever you want the bale length. So if you want a shorter bale, you would move this collar down here so that the star wheel has less travel before it trips. All right, now let's talk about the knotters because they're the most confounding thing on these balers. I found that they're pretty simple when you break them down, although them being out of adjustment can cause a myriad of problems. Having an owner's manual helps a lot because you can diagnose them. There's a whole chart in the owner's manual that tells you if the knotters are doing this or that, try adjusting this or that. But they can be very confusing. The first thing to do in explaining the knotters is to explain how the twine works. This is a twine box on the bale, and twine comes in balls. It doesn't come in rolls, it comes in balls, and it's got space for 4 balls in here, which would be 2 balls per side. You hook the balls together on each side so that when one ball runs out, it feeds into the other ball. The twine comes up from the balls, feeds through these holes, and then winds up going through these 2 holes, 1 hole for each side of the bale, and then through this tensioning device which keeps the twine tight as it's moving through the baler. Then from the twine box and through the tensioning device, the twine runs under here to a set of insulators that are on the back side of the needle carriage. The twine runs through those insulators and through this insulator and back through a hole in the needle, in the end of the needle, and it acts just like a sewing needle. So when the knotters trip and the needles come up, they carry that twine up to come to the knotters. Here I've hand rotated the baler so that the needles are halfway up into the baling chamber, and you can see what happens. The plunger moves rearward of the needles and the needles rise up in recesses in the plunger so that they're carrying the twine up into empty space, and then they come up carrying the twine to the knotters where the knotters grab the twine and do their thing. Here I've hand rotated the baler to bring the needles into their uppermost position. They've come out of the baler, up out of the knotters, and they're sitting here above the knotter here. So what we have when this has twine in it is we've got twine running through a hole in the top, there's twine running along the bottom, and there's twine running along the top. The twine running along the bottom has already been wrapped around the bale that came before it, and a knife here cuts that twine and forms it into a knot to complete that bale. The other end of that cut twine gets caught in the knotter. There's a friction plate where it gets caught in there and starts to form the end of the next bale that's going to come. After that's cut, these needles come back down carrying the twine with it, and they start wrapping around the next bale. I know it's complicated, but this is the best way that I can figure out to explain it. So after all this knotting business and being pushed through the chute, eventually the bales come to the thrower. Now this is a thrower, it's not to be confused with a kicker. A kicker is a pan that sits back here that the bale lands on after it comes out of the chute, and the kicker is spring loaded, so that pan springs the bale up and into the wagon. New Holland actually developed the pan kicker, but they elected not to use it because they thought it was too dangerous. Imagine if somebody was standing on it when it tripped. Anyway, this is a belt thrower. It actually catches the bales between two belts that are rotating and throws them out the back. This bale thrower is a later model than what originally would have come with this baler. This is a model 70 bale thrower. Originally, the bale thrower for this model would have been a 53A, which has more difficulty in adjusting. The model 53A would track with the wagon through a linkage that went on to the front of the wagon to turn the chute one way or the other, and it had a trip mechanism with a rope to adjust how fast the thrower was throwing the bales. A lot more complicated to work. This originally had a 53A on it when I bought it. I took the 53A off, I sold it, and I bought this model 70 and put it on the baler. The baler and the thrower are completely separate pieces of equipment. You can take the thrower off and just use the baler to load wagons or drop bales on the ground. Here's how the bale thrower works. You have the main flywheel on the front of the baler. It is driven by a belt that runs on the main flywheel up to this pulley here. There's an idler pulley here, and the way you adjust how far the bales are being thrown is through the speed that the belts are rotating in back, the big wide belts. And the way you adjust their speed is there's a crank handle that goes up to the tractor here, and what that crank handle does is it adjusts the position of the idler pulley, putting more tension on the belt as it moves inward. This pulley here is a special kind of pulley with two sheaves that move apart and together depending on the belt tension. So when those two sheaves are together, the belt is riding on the outside of the pulley, thus making the shaft that goes back to the thrower rotate more slowly. When you put more tension on the belt, those two sheaves move apart and the belt slides in, so there's a smaller diameter pulley that the belt is riding on, and it makes the shaft rotate faster. Pretty clever, I think. Now, from this front drive pulley here, there is a long shaft that's supported by intermediate bearings that comes all the way back to this pulley here. This pulley has a belt on it which goes around a right angle, which is pretty funky, drives this pulley, which in turn drives this pulley, which drives this flywheel, which helps give the bale thrower its own momentum, and from the flywheel, the top and bottom belts are driven via these pulleys. This is spring loaded, so that as the bale starts to load into here, the belts grab it, and they're tapered so that as the bale comes through, it does this and shoots the bale out the back. You can point this from side to side. Say you're going around a turn and you want to shoot the bale into the wagon, but the wagon's not straight behind the baler, via this hydraulic cylinder, which tilts it either way. The mechanical history of me and this baler is quite a long story. As I said, I bought it in 2013, and it ran all right when I bought it. The first year, I think we made 300 bales with it. And then at the end of the first year, I had a custom baling job for a neighbor, which actually paid for the $1,200 cost of the baler that I'd spent when I bought it. I took the thrower off the baler, had one on when I bought it, and sold it the first year, which I regretted a whole lot later on. We ran it for a couple years, and it started to develop some bangs and knocks. And so the beginning of probably the third year, we were up to making, I don't know, 1,000 bales. I decided that I would get a junk baler with a thrower on it and put the thrower on this baler and use the junk baler for spare parts. So I found one, and getting it is quite a story in itself, involving some locals who had a lot of junk. But eventually I got it back to the farm. I took the thrower off. Me and my dad put the new thrower on, and then over the next 2 years, well, no, let me back up. That same year that I bought the baler and the thrower, I went through this baler and replaced all the bearings on the plunger and some of the drive bearings on the pickup head, because the plunger was so loose, the bearings were shot, that it was banging actually when it made a stroke. And I also sharpened the knives on the plunger and on the baler body. They had hit a lot of rocks. They were pretty dull. Probably never been sharpened over the years. So I had, in essence, a smooth running baler, but I had this thrower that I'd bought off a junker baler that had been sitting outside for who knows how long, and the bearings in the thrower started going one by one, and I started by just replacing one of them at a time, and the bearings in the belts, on the rollers on the end of the wide belts on the thrower, are quite a bear to get out and replace, because you've basically got to take the whole thrower apart and to get at the bearing. So after replacing a couple of them, I said, well, shoot, I'm just going to go through and replace all of them. And I did that. And after that, the throwers worked great. Now, the year after I did that, we did 3,500 bales, and it's just my wife and I, and I'm throwing bales into 4 kicker wagons that we got, and we're having to come up and unload them in the barn, then I'm going back out and baling. Well, my wife and I are, you know, my wife's going to turn 50, I'm 52, and we decided this really isn't the way. So I had this baler that I'd painted, replaced the bearings in, did all this work, sort of new mechanically at this point, and I decided to go out and buy a round baler. So now this baler sits as a backup for the round baler, which I've never had any problems with. The round balers function perfectly since I bought it. And it sits in the barn. Now, I don't want to sell it because it's good to have a backup for all of our haying equipment, and I may wind up making bedding bales with it at some point in the future, but I'm pretty proud of it because I put all this work into it, and it's not something I would ever sell. It's like the old tractors I redo. The last part of this video is some tricks that I've learned to help these old balers run well, because when they're not running well, it's a real pain in the butt, especially on baling day when you're trying to get things done and you've got to screw around with the knotters most of the time. And the first tip has to do with the knotters. Make sure that you always grease every point in the knotter before you go out and bale. And there's a ton of grease fittings here. An owner's manual helps tell you where they all are. And blow the knotters off with compressed air. Get all the chaff and crap out of them. Blow back around in here, around underneath the hay dog where it can accumulate and keep the hay dog from working. All this, blow all this out. And sometimes if I'm baling for a long day, say I was doing more than 500 bales in a day, I would come in after I'd baled 500 and grease and blow off the knotters. It's amazing what a difference it makes. It can turn marginally function knotters into knotters that hardly ever miss. The next tip is to make sure that these hay wedges that are inside the bale chute are not rotted off. They're the first thing to rot out on the chute, especially if hay's been left in it over the winter. It'll just rot them right off. So you want to make sure you have the same number on every side. Sometimes you can get into funky situations having to do with the intricacies of how the bale chamber is being loaded, where you might want to run another one on one side than the other, but my opinion is you adjust the feeder knives to evenly load the bale chamber. You put the same number of hay wedges on each side, and you want to make sure that they're in good working order and not corroded out. Make sure that the hay dogs are working, that the ends aren't busted off the hay dogs, that the springs on the hay dogs aren't stretched out or busted, because you won't get properly shaped bales. You'll get banana bales and odd looking bales out of a baler that doesn't have the correct bale tensioning devices working inside the chamber and the chute. Next tip, take proper care of the baler at the end of the season. I see so many balers where they don't bother to clean the hay out. It takes like 10 minutes to clean all the hay out of the thing at the end of the season. If that hay sits in the chute, I don't care whether the baler's inside or outside, you're going to have more corrosion. If it sits outside, it's terrible because the hay's going to soak up the rain and the snow water, and you're going to wind up with all kinds of problems. Clean the baler out at the end of the season. I pour a little used motor oil over the knotters just to make sure that the shiny parts in the knotter don't get rusted up over the winter. Yes, you're still going to get some rust in the bale chute, but that'll clean out the first time you bale the next year. And if you're able, store the baler in a barn. Do not leave it out in the rain during the winter time. If you don't have a barn big enough to put the baler in, what I did is I used to take a couple pieces of scrap sheet metal like barn roofing, lay them over the top of the bale, put a tarp over the top of them, tie that tarp under the baler so that at least you're protecting the knotters. I always ran them to protect the knotters and the bale chute so that no water gets in there. Next tip, and I may not have the best answer for this. This is the best one that I've come up with, the best method. when you're hooking your balls of twine together in the storage area here, you wind up with a knot, and you make the knot like this. This is just the way the knotter makes the knot in the baler. So you've tied them together like this. Now what I've found is that you're most likely to miss knots on bales when this runs through the whole twine feeding assembly before it gets to the knotters, and it would inevitably miss a few bales as it was changing over balls of twine. What I found to help with this is to cut off as much of this as I'm comfortable with without losing its knotting capability, and then to take the knot and roll it in your hands like this so that you get that twine right along the side. And I would do this for a couple rounds to get it flat, and I found that most of the time when I did this, if it was oriented like this, I could get that to go through the knotters without having a big problem with untied bales at the end of a ball. And sharpen the twine cutting knives at the beginning of every season. The knives are right down in here on both sides. To get easier access, you just undo these two bolts and nuts here, slide them out, and then this whole thing will rotate up and you can get easier access to the knives. They can just be sharpened on a stone, just like a household knife, and that'll help the twine from getting bound up in the knotters if it cuts cleaner. If you're using sisal twine in the baler, buy good sisal twine. I found there's a real difference. If you go to, say, Tractor Supply and buy that junk that they're selling, there's thick and thin spots in the twine, and what happens is the knotters have a harder time holding the twine in place when it's at a thin spot. So I go to the dealer and buy the good stuff. It's really homogeneous, uniform as far as thickness goes. That helps out a lot. Remember, even if you do all these things and you clean out your baler at the end of the year, there's always an adjustment period at the beginning of every baling season. As everything shines up inside and the knotters get loosened up after you've lubricated them, you're bound to miss a few bales in the beginning adjustment period. You usually have to mess around with bale tensioning to get it right, and that's typical. And when it comes to making good uniform bales, that thing I said at the beginning of the video about flakes per bale makes a big difference. So, you know, you try and shoot for 15 flakes per bale, but obviously that's hard to hit every time. It's more like between 10 and 20 for me. But the big thing is, I would much rather bale in heavy windrows than light windrows. So if you're picking up a heavy windrow and you're really working the baler, you're going to get a well-shaped bale out of that. If you're picking up a really light windrow and it takes 100 strokes to make a bale, that bale's going to come out loose and it's going to come out misshapen. So if you have light windrows, you either have to increase ground speed quite a bit, and your field may be too bumpy for that, or while you're raking, double and triple those windrows so you can make them into heavy windrows and really make the baler work to make those good bales. I hope you enjoyed my little tour of my old New Holland baler. I think New Holland made the best haying equipment there was back in the era that this baler was made in the 60s, and it's a testament to how well they were made that 55 years later, with a little TLC, this baler is still perfectly useful on small farms like this, and there's a lot of small farms around that are still using them. So all it takes is a little bit of mechanical aptitude, and they're fairly simple machines, but very interesting at the same time. Thanks for joining me, and I'll see you next time.